This is lecture 4.2 from statistics, and we're going to extend this concept of the scatter plot. So if you recall in the last lecture, we were trying to see if the temperature outside predicted how long my dog wanted to walk, right? And let's assume we don't have any lurking variables and that there really is a correlation. So in this case, it's a negative correlation because they're basically looking kind of like the shape of a line going down as we move to the right. So the thing is that one reason that we collect all this data is so that we can then make predictions. So notice I had an observation when the temperature was 80 degrees, my dog walked 60 minutes. When the temperature was 90 degrees, my dog walked 40, and so on, right? But I don't want to have to wait for a day to represent every single temperature out there. Like, what happens if it's 81 degrees or 83 degrees? So what we can do is we can take the observations that we have, we plot them on the graph, and then we create what's called a least squares regression line. So in other words, what line would fit this data the best? You know, in other words, it's like what line basically kind of goes through the center of all that data. So we're looking for, it averages where all my observation points are. This line, just like back in algebra class when we learned about lines, all lines have an equation associated with them. And typically it's y equals mx plus b. If you recall, the m represents the slope and the b represents the y-intercept. So what is a slope and a y-intercept? Well, the y-intercept is where it crosses the y-axis. So if this was to continue up here, it would probably cross the y-axis at about, let's say, 90. Okay, so in this case, the slope of this line, the equation of this line would be y equals something plus 90, right? 90 is the y-intercept, it's where it crosses the x-axis. What's happening when it crosses on the y-axis is that x is 0, right? So when x is 0, that's when we cross the y-axis, and that's something to keep in mind when they're asking you to interpret the y-intercept. The y-intercept is always interpreted when x is 0. So that would be saying when the temperature outside is 0, how many minutes will my dog walk? My dog will walk 90, let's say, okay? What about the slope? The slope has to do with the rise over the run, the rate that this is decreasing. And so we would typically in algebra class, take 2 points and figure out how far the rise was. That's about -20 from 90 down to 70, and how far the run is, and let's say that's 60 or something. So -20 over 60 reduces to -1/3. So my slope would be -1/3, and it's always next to the x. So the slope is always next to the x, and the y-intercept is always standing alone. It's the constant. It does not have a variable x attached to it. Okay, so what's important here? Your StatCrunch will tell you the equation of your line that goes through your data. Some things that are important are words that they use to represent different parts of this picture. So my dots from my scatter plot are my observations. These are actually what I saw. I actually went out, and when the temperature was 80, the time was 60, so I've got that dot there. Okay, this is an observation. The line represents the average of all those observations. So oftentimes they use the word average to talk about the line. They may say, was this observation above average or below average? Well, it was actually higher than what the average would have given me. In other words, if I had taken the equation of this line and plugged in 80 degrees, it would have given me a slightly different result than what I actually observed. My observation was above my average. My average is the line. Another word that they use to represent the line is your expected value. Well, what did you expect would happen at 80 degrees? Well, I expected it would be more about, 56 minutes or so, but my observation was 60. So what's going to happen is that you're going to have a set of data. You're going to go into StatCrunch, just like you did in 4.2, and you're going to do stat, regression, simple linear, and it gives you that 2-page response, okay? And part of the response is the equation of the line that is your least squares regression line, which should have the same slope as your data, as your scatter plot. It's going to ask you for the equation of that line. In StatCrunch, it writes it, and what it does is it switches the order of these. So it will actually write it as y equals b plus mx. And it doesn't matter that it does that, but what you want to do is recognize that the number, the coefficient next to x is the slope, and the number that doesn't have the x is the y-intercept, so that you can plug it into the answer for the question as you're going through, okay? Then what it's going to do is it's going to say, all right, well, I want you to use the equation of the line to tell me what happens at, let's say, 85 degrees. If I wanted to know how long my dog would walk at 85 degrees on average, and I didn't actually have an observation, then I would plug it into my equation of my line. So let's say I wanted to know that. I would go, well, y equals -1/3 times 85 plus 90, and I would calculate what the answer would be, and that would give me my expected answer for 85, okay? So it would give me whatever that little dot is there on the line. The reason we do this is so that we can make predictions, right? So another word that they use is predicted. So this line gives us the knowledge to make predictions so that we don't actually have to collect observations at every single temperature. So when we use the line, we're only allowed to use it to make predictions within the scope of the original set of data that was given us. So in other words, to be honest, the 0 for x is out of the scope because I did not have any observations that went down as low as 0. So in my situation, I had my lowest temperature was 70 and my highest was 114. So I can really only use my line to predict responses for values between 70 and 114. Anything else is out of the scope of that line of prediction. And that can be a little bit weird. I try to explain it pretty thoroughly in the homework help, but let me know if you need a different explanation or if you don't quite understand it. Okay, and then the last thing that they talk about is what's called a residual. Obviously, if I plug 80 into my equation, based off this line, I'm going to get an answer that's right about here. But my observation was up here. So the difference between my observation and my expected value on my line is what we call a residual. And how do we calculate the residual? We simply take the expected value, we take the observation, which in this case was at 80 degrees, my observation was it was 60 minutes of walking time, minus the expected value, but again, they may use the word average or the predicted value. So my expected value, when I plugged it into the equation of my line, gave me, let's say, 56. So minus 56. So my residual in this case is 4. In other words, my actual observation was 4 minutes more than what my expected value was when I used my predicting line. Had my observation been lower, like let's say here, then I would have gotten a negative number showing that my observation was below the average, okay, because it would have ended up with a negative. So let's say this was like 42, but this was 53. So my observation was 42 minus 53. So that's negative 11, which tells me that my observation was below the average line. And that's basically it. I don't want to go into too much detail into the lecture because it's just a lot of information. I would encourage you to start the homework problems, look at my homework helps, because I try to explain step by step what's happening there, and then maybe come back and revisit this, or else hop on during class time and ask me the questions that you have. This can be a little daunting for people. This is a lot of math all at once, right? We didn't have quite as much math in chapter 3. You know, we've got the graphs and the equations of the lines, which many people aren't that comfortable with. So just try to breathe, and I will also do 2 questions on StatCrunch. All right, bye.